So you've built a chatbot prototype. It's pretty cool, it's impressive, it gets oohs and ahs in the demo, but is it actually production ready? Let's talk about that giant leap from a clever demo to a reliable, scalable, and safe system that a real business can bet on. We're moving out of the playground and into the real world.
And really, this quote just nails it. The source material puts it perfectly. Building AI that works for a business isn't just about the cool model. It's a full-stack challenge. It's the AI plus some serious engineering plus strict governance and a sharp eye on the costs. It's the whole shebang.
Okay, so let's really unpack that gap. The difference between a simple chatbot and a true enterprise system is huge. We have to go way beyond just having a clever conversation. We need to build something that's safe, predictable, and doesn't break the bank. It's a whole different ballgame.
All right, enough with the theory, right? Let's look at how real companies are actually pulling this off. We're going to dive into a couple of very different case studies to see the clever engineering they're using to solve these exact problems.
First up, we've got a tool designed to automatically create weekly financial summaries, pulling data straight from internal databases. Now, this is a super high-stakes task. I mean, it has to be perfectly accurate, totally consistent, and lockdown secure. There is zero room for error here.
So check out how they tackled two of the most classic LLM headaches. First, the model would sometimes spit out broken data, in this case, malformed JSON. So they engineered a fix, a validation step that checks the format, and if it's wrong, it just automatically tries again. And to stop the model from making stuff up, hallucinating, they used a super strict prompt that basically commanded it to only use the data it was given. See, that's real system design, not just fiddling with prompts.
And the result of all that engineering? Get this. 22 hours of manual, mind-numbing work, just gone. Every single week. That is literally more than half of a full-time employee's entire week just automated away. This shows you the massive business impact a well-designed AI system can have.
Okay, let's switch gears to our second case study. And this one's really cool. It's an internal tool for developers, an AI assistant built to help the company's own engineering team code faster and better. It's pretty meta, right? AI, building the tools for the people who build with AI.
And the setup here is just, wow, it's so smart. It's not just using one big model for everything. They built a model router. It's like a traffic cop. It sends the hard coding problems to a powerhouse model like GPT-4, but for simple questions, it sends them to a smaller, way cheaper model. It's also plugged right into their code repository, Git, so it can suggest changes directly. And maybe most important of all, it has a security check to make sure it never ever leaks secret keys.
And the punchline here? A 28% increase in developer productivity. I mean, seriously, ask any tech leader what they do for a nearly 30% productivity boost across their entire engineering team. It's an absolute game changer. That's the power you unlock when you go from a simple tool to a deeply integrated system. Okay, so we've looked at finance and we've looked at engineering. Totally different worlds, right? But what's so fascinating is that underneath it all, they're built on the same core ideas. Let's pull back the curtain and look at the universal patterns that all these successful systems share.
And here's what those patterns look like. First off, pretty much everyone is using Retrieval Augmented Generation, or RAG. That just means they're giving the AI a private knowledge base so its answers are grounded in facts. But, and this is a huge but, it's always surrounded by guardrails. We also see that smart model routing, like we saw with the coding assistant, is a huge theme for keeping costs down. And when you have the essentials, audit logs for when things go wrong, feedback loops so the system gets smarter, and of course, a human is always kept in the loop for any big decisions.
And if you're wondering why that model routing thing is such a big deal, just look at the money. This chart shows it all. By being smart about which model you use for which task, companies are slashing costs by up to 45%. So the point is, a smarter architecture isn't just better, it's a whole lot cheaper to run.
So if all these successful real-world systems are using the same tricks, does that mean there's a kind of universal blueprint? A playbook we can all use? You bet there is. This is the architecture that ties everything we've seen together. This is the real playbook for production AI.
And this is it. This is the blueprint. It starts with the user's request, which right away gets cleaned up and checked for safety. Then, that smart router we talked about picks the best and cheapest model for the job. Next, the main logic kicks in, often using RAG to pull in factual data. But here's the most important part. Before the user ever sees a response, the output gets checked by a validation layer with guardrails. And finally, everything is logged and monitored, which creates that critical feedback loop to keep making the system better. This is how you build an AI system you can actually control.
So what this all really points to isn't just a new way to build things. It's a totally new way to think about AI. It's a fundamental shift in mindset.
And if you remember one thing from this whole explainer, let it be this. LLMs are not just models, they are systems. We have to stop thinking of them as just this magical box we send prompts to. It's the reasoning engine at the very heart of a much larger system that we have to engineer, govern, and observe.
So what do we even mean by system in this context? Well, it means you can actually see what's going on. It's observable. You have control. It's governed. It follows the rules. It gets better over time. And it's economically viable. It's a true engine for your business, not just a temporary spark.
So that's the question I want to leave you with for your own projects. Have you built a clever tool that kind of works sometimes? Or are you engineering a complete, robust system that your business can truly depend on day in and day out? Because the difference between those two, well, it's everything.